So I've implemented this code for the even square values to find the starting position and to add that column and row to the matrix. I haven't actually checked that it works yet, so that's what we're going to do now. Okay, so what I've added is I've checked the dimension of the spiral to see if it's even or odd, and based on that allocated the first even square term position and the first odd square term positioning. Okay, and that's just based on what I found in the previous section of this cast. So I have two cases for that, one where n is even and one where n is odd. And then based on those, now in my for loop, this first section is the same as it was before, but I've added this chunk of code down here, which is a fairly large piece of code, so I'll just run through that now. Actually, we'll step through that together. So I want n to be even the first time, so that I can get straight into this. Okay, so n is 6, test n should be 6. All of this code I've checked, but I'll just make sure my new row is right. Starts at 36 and goes down to 31. My column starts at 31 and goes up to 26, so I'll just check that that looks like what I want it to. Okay, so 36 down to 31 and 31 down to 26 looks correct. Okay, so now the next thing I've done is I'm using the positions that I have here to know where my square number is, but then as well as knowing where my section starts. So in the case of 36, I know that I start in the 6th or nth row in the first column. I also need to know where my section ends. So I know that for n equals 6, my index will be 6, which is 1 plus 5. So this row or this vector is 6 elements long, but the distance between the two indices is 5. So that's what I'm using this piece of code here for. This calculates the length of the vector that I'm adding, and then I subtract 1 from it to make sure that I get to the correct location. So then I say what the row index is to place the row. So that's row 6, which we just saw, and then the first column is the location of my square number, which is in this case 1, and it should finish in column 6 in this case. So when I calculate this, this is column 6. Okay, and then I just assign my new row to that location, so into the 6th row and from indices 1 to 6. So if I look at that now, that is actually the row that I want, so that's good. And then similarly for the columns, I've done the same thing. So we'll double check that that all goes to the right position, which it does. So my rightmost column is now filled with the values. And then at the end I increment, or I update the location of my next square number. So I started with 6, the next even square will be at a position of 1 row lower and 1 column higher. So if I run to the next breakpoint where n is equal to 4 and step through this again. Okay, so now I have 16, 15, 14, 13, which are in these positions, which is the correct location. Then I'll check that the column goes to the correct place. So the second furthest column, I have 10, 11, 12, 13. 10, 11, 12, 13, which is what I should have. So that's operating correctly. Now I'll just fill the rest of this out and then check in my command window what I have. So 4, 3, 2, which are these values here. So this is operating correctly. Okay. So now what I need to do is add similar code to this, but for odd values of my square numbers. So I'll have to use these terms and then update my indices appropriately. So now's a good chance for you guys to have a go at that. And once you've given it a shot, we'll come back and see if we can finish this off.